Yeah, I'm just gonna do the presentation if that's okay. So hi everyone. So I'm gonna basically talk about how I manage my health with connected field service. Just a bit about me and my background. So my name is Tricia Sinclair, and I am a D365 pre-sale solution architect from DXC Technology. I do like to blog. I mainly blog about Azure DevOps and Omnichannel. If you'd like to read more about that, please subscribe. You can also reach out to me on Twitter and LinkedIn. If you've got any questions about the presentation I'm going to cover, then just reach out to me there. So this demo, this presentation is really going to be around how I can manage my health through connected field service, which is typically an edge case scenario, especially when we think about connected field service. And I'll tell you why. So I'm going to focus on, first of all, what exactly is connected field service? I know we're having a lot of sessions about, IoT devices, etc. But what exactly does it actually mean? Like, what is connected field service? Then I'm going to go into the scenario and the background to the scenario before I go behind the scenes to talk about, well, how it's all put together. And then I'll also show you inside of the system how it's put together as well, and then talk about some of the real world situations in which this could apply to. Okay, so firstly, let's go into understanding what connected field service is. So connected field service is typically, when I hear of connected field service, it's always with the idea of a field service engineer going out to fix something or provide a particular service. But when you talk about connected field service, it's more about being able to get data. So each device that we're actually getting nowadays, they're transmitting data. They're all smart. And in that way, so for example, you've got your Apple Watch, you've got your TV, you've got your, to be honest, even medication nowadays can actually transmit data, right? So with this data, what we can actually do is we can gain insights from it. We can understand and analyze that data in order to understand if we actually need to do something. So effectively, connected field service allows us to gain insights from IoT devices in order to actually take action, right? That's pretty much what it is. Then we are able to then leverage field service to extend it and use, standard D365 functionality to enable us to make it easier for whoever is going to take that action to create like work orders and schedule, etc. So that to be. So in the scenario that I've created, these are all my devices. And this is where I'm going to get a little bit personal with you. These are all things I pretty much suffer from. I have insomnia, I have hypertension, blood pressure, and to be honest, I struggle with my weight. So these devices really help me with that, okay? So the sleep mat is a smart sleep mat. It's transmitting data, and the telemetry that it's transmitting is my heart rate, how long am I snoring, how deep am I sleeping, how long am I in a deep sleep for, etc. And then you've got the blood pressure monitor, which is actually tracking my ECG, my systolic and diastolic pressure, and my heart rate as I sleep, as I go through my day, and my body cardio, which is basically tracking like my fat to muscle ratio, etc. Now, all of these devices are built by one manufacturer, Withings, and it's really perfect because what they do is they allow us to interact with this data, not via a hub. So in typical connected field service or in typical IoT fashion, what you'd expect is you'd expect to either retrieve that data as it goes, or you'd be able to interact with a hub. But what they've done is they actually are sending this data to their hub. They've provided an API that we can then interact with to pull the data from these devices. Okay, so we're not getting continuous data. What's happening is each day I'm actually pulling data from the devices and I'm pushing it into my system so I can then analyze and decide on what I need to do. So when I actually pull the data from these devices, effectively what I get is I get what's known as JSON, which is like a formatted, it's basically formatted in data that I can then use to manipulate and do anything else with it. So this is actually the data that I'm getting. So the key things here is the group ID, which is the unique identification for the different measures that I'm taking. I also have the device ID to indicate which device it came from, and each device has different measures. So for example, here, this is type 9. I know that type 9 for me is systolic, is a systolic measure. Type D is diastolic, and I'm just looking at the type and I'm looking at the value. Now, one of the things that I have is in terms of hypertension, my problem is my diastolic, right? So because my problem is my diastolic measure, the what I want to know is if it goes over a certain amount, because if it goes over 120, then that's basically cause for concern. Mine is consistently over 120. So I want to know why, and I want to understand the trend. When is it getting high? Is it actually getting lower? What am I doing at that time? And as you can see here, the JSON's quite nested. So I'll also show you how I've actually flattened it and how I've actually then used this. So what's actually happening behind the scenes is that we have the health devices, as I mentioned. So that's my scale, my blood pressure monitor, and my sleep mat. And I'm pulling these devices each day and pushing it into the event hub. Now, the connected field service, when you install connected field service, it comes preset with particular resources in Azure. So for example, one of them is the IoT hub. I didn't use the IoT hub in this instance because, to be honest, with these devices, I'm not pushing any data back. So I'm not actually sending any commands or sending any device properties back to the IoT hub. Therefore, I didn't really need to use it. So I created an event hub and I'm pushing the data to that hub instead. Then what I'm doing is I'm unifying the data and then I'm analyzing the data using stream analytics. So within stream analytics, there's also something known as stream analytics anomaly detection, which basically uses machine learning to help predict, based on trend or based upon spikes or dips. And I'll show you a little bit about how I've actually done that as well. Now, the other thing as well is I'm then using a service bus, which is connected to my stream analytics job to then push data in to the common data service via a logic app. Now, the logic app that I'm using is now the standard logic app that's provided by connected field service. So if I go into the system, I'll show you how I've set each of these up and what's actually happening behind the scenes. By the way, this is a pet project, so it's actually not finished, but the bit going into IoT, going into CFS is, so I'll be able to show you that. So if we start off, so bear in mind, I mentioned that we have the data that we need to pull from Withings, and they provided an API. So what I did was I created a custom connector with the Withings API. And basically, this is what it gives me. So it gives me the one action, get measures, which basically gives me an example. It uses the example response that I showed earlier for the JSON. So that's actually what I get back from this action. Okay, now when I get back this action, what I can then do is, so using Postman and the collection, I exported it, I created the custom connector, and then I can use that custom connector in my logic app that I created. So here you can actually see that each day I am basically using my custom connector to call my action, and then for each measure that I get, so each group, it's basically sending an event to the event hub. Okay, so with that, what I then get is data in my event hub. Now, I hope you can actually see this. Let me know if it's too small and if I need to maximize it so you can actually see it a little bit more. Let me just zoom in. Okay, hopefully that's big enough. So now what you can actually see is this is actually the event hub, and I'm basically testing the query that I'm going to be using for Stream Analytics. So with Stream Analytics, what you can actually use is like a SQL kind of syntax to query the data, and also you can then call out to other functions like JavaScript functions or even machine learning standard functions. Okay, but here we've got some examples of where we're using the SQL, we're using the machine learning functions as well. So I'm basically calling and getting the necessary data that I want to push through or use to identify my trend. And here what you can actually see, so anomaly change point is basically what I was mentioning before with regards to the Stream Analytics anomaly detection. So with Stream Analytics anomaly detection, here you can, the syntax for that is basically where I'm saying that I want, this is my confidence rating, how confident should the model be with that result, and also how many events needs to be in the window itself, and for how long. So what's the frequency? So it's only going to look for the past day for this amount of events, and this is my confidence rating. What this will then give me is two outputs. This is going to give me how the change point in terms of how many points has it changed, but also it's going to give me any anomalies. So if you notice if there's a trend where it's continuously changing for like 2 or 3 points, and then all of a sudden something changes to like a greater amount, then it will detect that, and it will actually be available in what's known as a change point anomaly. Okay, so you can also then do anomaly detection with that as well. So within machine learning, this is actually using a time series model, which is really hard to do if you're actually going to create it directly within your Azure Machine Learning Studio. Trust me, I tried. It's really hard. So this really is a really useful shortcut to providing a trend analysis. Now, what I'm doing here is I'm actually flattening my array. So I mentioned how the array was structured. So with using get array elements, I'm basically getting the data that's inside of the measures property, and I'm then able to use that in my SQL. Okay, so now that I've actually done my test, you can actually see the expected results from the last run that I did. So the readings and the diastolic pressure. By the way, so this is actually for systolic. I've also done the same and grouped it for diastolic as well before basically pushing that into the alert queue. So the alert queue is my service bus. So I haven't changed it too much from the standard connected field service setup that you would actually get. Okay, so what actually then happens after that is I've actually stopped my Stream Analytics job. I input it into the query, restarted it, and then that is going to push now the information into the data that it's getting into the job. So I can then run the logic app will then be triggered to push data into CDS. So here you have the inputs. Obviously, one of the inputs that I then added was the event hub. Okay, so what does it actually look like when it actually gets into the system? So if I just bring this up, so what I then end up with is this IoT alert, which should look quite similar if you are familiar with field service. So with field service, you obviously get standard entities. One of them is the IoT alert entity. So here you have the alert data that's actually being pushed from the device with the date, which actually is still in a Unix format, but you can actually change that in Logic App. You have the change point anomaly and the change point score, but this actually didn't come through because what I did was I wanted to know if the reading was over 120, because as I mentioned, that's actually one of my problems. I need to keep it over 120, so under 120. So I'm trying to make sure that that actually happens. You can also see the device that triggered it because of the device ID, and you can see that it's associated to myself as well. Okay. Now, in terms of then taking it further, where I want to go with this, now where I will continue to work on this, is now that I've got the alert in, what do I then need to do? So is it that I then create a case and then create an appointment, or do I just go straight to, generating something else? So pretty much this is as far as I got to in this scenario. But what I also will be doing is linking it to Health 360. So one of the other things is with the Common Data Service, you have what's known as accelerators. Accelerators extend the standard entities that are available inside of CDS, right, based upon different industries. And one of the industries it has is healthcare. So this model is based on FHIR, which is used within a lot of healthcare countries, or different countries with regards to healthcare. It's also used in the NHS, and that's basically a standard data model that they all adhere to. So that is actually what's being used for Health 360. So here you can actually see my patient record, and the reason I'm coming here is because eventually, like in the future, and I'll blog about this, I will be linking the Connected Field Service to Health 360, because here you actually have the ability to have what's known as observations. So each update that I take, so each time I do my blood pressure measurement, what could then happen is it could then add a new observation here, enabling my doctor to actually see this and actually take action if they needed to, or this could actually be utilized as part of my care plan, my care plan. Okay. The other really useful thing is with regards to the IoT alert, we should actually leverage appointments to automatically generate an appointment with a case for someone to actually contact you, because this is actually what's used. So it's basically how they could actually be merged together. Okay, so if I just go back to my demo. So in terms of real world applications and how could this be actually done in the real world, or the benefits of doing it in the real world, really, what this really allows us to then do is pretty much personalize patient care. Currently, I have to go to the doctor every 3 months to basically get my kidney checked and everything else just for my conditions. But what I would hope for is if we leverage connected health in this way, and we shared information across like the hospitals and the doctors, then this really will enable us to have a more personalized care plan, if that makes sense. So for example, a few years ago, I know a trial was taken where a group of cancer patients used like Bluetooth enabled scales, a blood pressure monitor, and a symptom tracker to then send updates to a patient's physician every day. And that trial actually found that patients ended up experiencing less severe symptoms that was related to both their cancer and their actual treatment, because the physicians were able to identify the side effects a lot quicker and then ease their burden. So it was actually a better and personalized care for them. So effectively, that's a real world example that's helping actual patients using smart devices, and that could actually leverage Connected Field Service. With that, we can actually reduce doctor visits as well. So obviously, we're in the situation where unless you have to go to your doctor, you shouldn't go. So we all pretty much have at least 1 or 2 bits of smart tech that will track your health. We all have like a watch or even a phone that's transmitting this data. And this data could actually be used to help doctors identify or help doctors to diagnose, rather, if you actually need to come to the surgery, or if it's something that they could actually do remotely, because obviously we do need to factor that in right now. Now, one of the other things that I have been looking into is being able to detect or diagnose illnesses pretty much before it becomes too too problematic, so to speak. So I have a list of historical diabetic information, and I've imported it. Being able to create a new patient record, and based upon the information that you know of, based on past diabetics, whether or not this person is likely to have diabetes, whether or not you should actually send them straight away for a diabetic check. Again, this is something that can actually be achieved using exactly the same demonstration or walkthrough that I've just done, and even being able to predict potential future issues. For example, are you on the path to becoming a diabetic based upon the information and based upon historical information? So basically what I'm saying is connected field service is not just for that typical scenario of an engineer, we need to go fix equipment, but we can also look at the other side of connected field service, which could actually be to actually help humans, help patients, actually better and improve their life. Okay, now that's all I've got. Are there any questions? Do we have any questions?
Well, Tricia, this is Sean. That was awesome. That was a really cool way that you addressed a personal issue and kind of modeled it with IoT. How difficult was it for you to create the custom connector between the Withings API and to create the Logic app?
That wasn't hard at all. That was actually one of the easiest bits. Because I used Postman, and because you can actually export a Postman collection and just import it to Logic apps, it wasn't hard. And there's a lot of information out there that actually walks you through step by step as to how to create that custom connector using Postman, or even manually if you wanted.
Very cool. Very cool.
There are other health systems. So, for example, I know MyFitnessPal has an API. I know Samsung has an API. So, depending on the devices that you have, if you reach out and you look for those APIs, they are available, and you can actually just leverage them.
Always wanted to play with that, but I guess I was just a little too lazy to really try. So I'm a little bit inspired now. Thanks, Tricia.
You should.
Yeah, there's lots of different devices. I tried this a little bit with MyFitnessPal, but they don't give you a developer account to connect to their APIs without being on AppSource and stuff. Is a bit of a pain. I know that it's cool to see how you're doing that. Any other questions from anyone? No? Okay, Tricia, do you want to let everyone know where they can find you on social media, or if they've been scared to ask any questions, where they can go and ask you questions?
Sure. I'll just share my slide deck. So if you do want to reach out, talk to me a bit more about this, give me some more ideas that I could actually build into this, reach me on Twitter or LinkedIn. So these are my details. Literally feel free to just connect with me there.